Here we have a crucial SSD drive that came in for data recovery. The drive looks something like this, and this one is a 500 gigs SSD drive. Customer wrote, the SSD stopped working and has very important data. In case it does not work, is it possible to recover the data? We are not working on this drive for the sake of fixing this drive. We are working on it to access data. And when we are able to read data, then we're going to transfer that data onto a USB flash drive, and that's what we will mail back to you. So let's go ahead and work on this drive and see what's going on. The first thing I want to do is plug the drive onto the computer. And I want to see if we hear a tone or if there's anything obvious, any signs of life. And right now we did not hear a tone and no signs of life at all. If we go to disk management, I'm not able to see it in disk management as well. Okay, so we know that the drive is completely dead. What's the success rate of this drive being fixed? I always tell customers 50-50 chance. We may be able to fix it or we may not be able to fix it. SSDs are complex. If the problem is the NAND chip, the controller chip, then we cannot get any data. If it's anything else on the board, then we should be able to fix it. But I do not like to set the bar high. Data recovery labs, they charge $1,000+. We're not that expensive. You can expect to pay half or even lower. It doesn't matter what the problem is. We could just blow on that drive, we fix it, and you pay the same price. That's data recovery. If you want to go to data recovery labs and pay $1,500 and $2,000, by all means, you can do that. So I got the board out right here. And the board is small. A very tiny board. We have NAND chips and we have the controller chip. That's basically the board, like a USB flash drive. Not much going on the board. So we're going to switch over to our V2 microscope and let's see what's going on. We're going to inspect the board to see if there's anything obvious. Is there anything that we can measure here? We can probably go over some capacitors. Oh, whoa, whoa. Whoa, look at this. A capacitor and an inductor. Look at the inductor. Look at this. We can tell it's an inductor by the look of that component. And we also see the L marking on the board. And that's a capacitor. And both of them do not look good. Whoa. And that's the great thing about visual inspection. Sometimes you can tell what the problem is by just looking at the board, looking at the components, without doing any measurements. Let's go to continuity mode. And I want to see if this capacitor is shorting to ground. And the cap is not. I'm reading 364 ohms, and that's not a short. What about the inductor? Is it continuous? And the inductor is continuous, but it does not look good. And I'm reading 0 ohms here. What's going on? I'm reading 0 ohms here. The inductor is continuous even though it has that bulge onto it, and this cap is not shorting to ground. 366 ohms. Are we supposed to read 0 ohms on this cap? I do not have another donor board for a similar drive, so I cannot compare measurements. If we randomly measure capacitors, we do not have a short. We do not have a short. We do not have a short. No short. But we do have a short right here. Is it possible that this capacitor is bad? Or is it something else? We know the inductor does not look good even though it's measuring continuous. And I do not know the value of the inductor. Let's start by desoldering the shorted cap, or the cap that measured for a short, and see what happens. I mean, worst case, we can inject voltage on this cap and see what gets hot on the board. But I'm gonna start by just removing that cap using our hot tweezers. Just like that. We're gonna go to diode mode and we're gonna measure to see if we have a short on the board. We should get a short here because this should be ground. Okay, so I'm measuring nothing in diode mode and I'm measuring nothing in diode mode. Why? We can check from here to right here and I'm not getting a reading. How come? So I'm reading a short from here to here. Is that normal? That's not normal. One of them should not be short into ground. And I believe this should be ground here. And this may be connecting with this. Okay, why don't we inject voltage and see what gets hot on the board? Right now it's going to be very hard to know what is causing the short, but we do have a short on those pads, one of them. And for now we're going to ignore the inductor because we are reading a continuous path even though the inductor does not look good. And we can assume that this cap is good, it's not short into ground, but it is discolored, and that's probably because this inductor released some smoke, probably, most likely. Or it overheated, releasing some of that factory flux that is found under components sometimes. So we're going to start by injecting about 1.5 volts. Ground probe connects here. And let's go over to our thermal camera. And now we're going to inject voltage and see what happens. I'm injecting voltage on the right side of the cap and nothing got hot on the board. Nothing. The other end is closer to the resistor. If we inject voltage there, I'm also not seeing anything hot on the board. I'm not seeing anything hot on the board. Why don't we bump up voltage to 2 volts? And nothing. That hot spot that you see on the board is actually a screw hole. It's a reflection. And if we bump up voltage to, let's say, around 2.5 volts, what happens? Still nothing. What's going on? If we are measuring for a short, then the meter must draw some amps if we inject voltage. Even if we inject voltage onto ground, the meter should draw a lot of amps, but I'm not able to draw any amperage by injecting voltage at either pads. 0 amps being drawn and 0 amps being drawn. If we inject voltage right here, I'm injecting 2.5 volts, 0 amps being drawn and 0 amps being drawn. Nothing. What if we touch ground with positive? Now I'm drawing 1.9 amps. So yeah, our ground probe is making a connection. So we're gonna assume that this is not a short. Let's go to diode mode and measure again in diode mode. And now I'm not getting any readings in diode mode. So what if we go to continuity mode? And nothing. I'm not reading anything in diode mode and I'm not reading anything in continuity mode. What if we measure resistance? What is the resistance between either pads to ground? 27 26 mega ohms. That's not a short. And we have 27. No, we have 40 mega ohms here. And we have 40 mega ohms here. So this one is acting like a line. One straight line. Is it normal for those two pads to be connected to each other? It doesn't make sense. There's a problem. What if we measure the capacitor that we removed right here? If this cap is not measuring for a short, then we're gonna put it back. What is that mat I'm using? Because mine is burned and this one is not. I'm using this mat. I went over it in a video a while back. An amazing silicone pad that has a lot of friction. So if I have a device on that mat, that device is not gonna slip. And it takes a lot of heat. I'm always soldering at 500 degrees Celsius with my hot air station. And look at the way the mat looks. Not even a burn mark on it. Some dirt, but not even a burn mark on it. You can find it on our site. Just search matte or silicone or heat resistant, I think, and you'll find it. Matte or pad. Just search for one of them. Right now we want to be able to figure out what's going on here. I wish I had a donor board so we can compare values too, but we do not. And right now we're just assuming and guessing. But I know that those two pads should not be touching. It does not make sense for those two pads to be a straight line and then to have a cap soldered on top. So one of them should be ground and the other one should not be ground. But none of them are measuring for a ground in diode mode. Why is that? Let's measure this cap in continuity mode. And let's pray that this capacitor does not fly over to the 9th dimension, because if it did, it doesn't matter, because the cap is not going to affect us being able to get data. I'm reading OL. OL is a good thing. So we know that the cap is not shorting. We're going to put it back. And just a tiny bit of flux right here. And we're going to apply just a tiny bit of solder. And put that cap back. I do not know what's on my soldering iron, but I just cleaned it. Okay, I thought I lost the capacitor. And with our hot tweezers, we're gonna grab it. And we're gonna solder it back. And of course we can go like that, and we can go over it one more time. Right? That ground wire keeps shifting the board. Let me get rid of it. The board is very small and very lightweight. So if you do not have it in a board holder, you're gonna suffer. And that's what I'm doing now. I'm trying to figure out the problem before I put it in a board holder. I work backwards. I should put it in the board holder and then do work on the board. But I want to figure out the problem before I put it in a board holder. Awkward. Why do I do this? Sometimes, I don't know. I still do not understand myself. And now if we measure in diode mode, we're gonna get a beep. Diode mode, we're gonna get a beep. Should we remove this inductor? Even though I do not think that anything is gonna change by removing the inductor, but the inductor does not look good. Right now we are running out of options and we have to do something. Look at this. Look at this inductor. It just split in half. Nice. Okay, let's get rid of it. We're gonna use hot air because hot tweezers will not be able to remove it. This inductor is cooked. And now since we opened up the circuit, not from here and not from here, not from here and not from here. So what's going on? Let's go ahead and replace this inductor if we can find a similar one somewhere. I do not know where I'm gonna find one like that, but we're gonna have to look. We do have inductors, but they are not the same. Oh, here, maybe we can use this one. Look, look. Maybe this one is a bit smaller, but it's better than nothing. Let's see what happens. I'm in diode mode right now. You know what I think? This is not ground. I have my red probe here, and I'm not able to get any reading on any components. So this is not ground. Okay, so this is ground here. And let's measure against this. If we go here, actually this is not ground. So before we were not able to inject voltage because I connected ground to the screw hole, but the screw hole is not ground. That's the mistake that we did. Okay, so we're gonna connect ground here, and then we're gonna inject voltage. And let's see if that works. Now that we have our probe connecting to ground, which is this pad here, if I put my probe right here, and I'm still not able to inject voltage, you know what, I'm just gonna solder a wire to that pad, because we're not able to make ground connect or make a connection with that pad. So let's add some solder here, and we're gonna add a wire, and then we're gonna connect the clip to that wire. The board wanna play games. Now we can connect our ground probe right here. We are experts at playing games. If we inject right now, yes, we are getting an amp draw of 2.5, so something must be getting hot on the board. Let's see what's getting hot on the board. All right, so now that we have our ground cable connected to that wire that we just soldered, let's inject voltage and see where the short is coming from. I'm gonna inject voltage at the inductor. Whoa, 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 whoa. Our NAND chip got hot all the way on the top left. I mean, two areas are getting hot. Where I'm injecting voltage is getting hot, and our NAND chip all the way on the top left. And if we look carefully, heat is not coming from the chip itself, but it's coming from the side of the chip. That's the chip, and that's the side right here. Let's look at this one more time. Okay, so we're gonna have to look and see what's on the side of that chip. I mean, how lucky would we be if we had a capacitor on the side of the chip, and it looks like we do, and that cap is short into ground? How lucky would we be right here? Heat is coming from exactly here. So it's very likely that this capacitor may be short into ground. If not, then most likely the chip is what's short into ground. which deems this repair a no fix. But let's go ahead and remove the cap and see if anything changes. How lucky are we feeling today? Because it's going to take a lot of luck to have a shorted cap and not a shorted chip. My tweezer just fell on the floor, and look at this. Look at the way it's looking now. What can you do? And all because of my wife. She called me, I answered, and I dropped the tweezer. All on her. Nothing to do with me. Whoa. The cap is shortened to ground. My God. We got it. We got it. We do not need this cap anymore, and we do not have to replace the cap. All we need is the data from the drive. And right now, hopefully, the inductor we replaced is not going to prevent us from getting that data back. Let's see. I did not hear a tone when I plugged the drive in. What just happened? Let me plug it in. And I'm not seeing any files. Oh, whoa, yes. Got it. Wow. Okay, so let's go to this PC, and the drive is right over here. I'm gonna disconnect. All right, and we're gonna connect again. Yes, awesome. Got it, we did it. One tiny capacitor disabled the whole board. We got rid of the cap, we replaced the inductor, and the drive is working. Let's go ahead and measure to see if we still have a short. Meter in continuity mode. And if we measure from here to here, we no longer have a beep. We have a beep here, but we no longer have a beep here. And that's because we got rid of the short, which was caused by this cap right over here. The power of using a thermal camera. If it wasn't for the thermal camera, it would have been very difficult to know that this cap is what's causing the short. Just imagine, you do not have a thermal camera. Very hard. So we did it. Let's desolder this wire. That's it. We did it. Let me know what you think. I hope you enjoyed the video. Don't forget to like and subscribe. Leave a comment if you have any questions, and we'll do something else in the next video.